All right, this is Steps of the Scientific Method. This is your teacher, Mrs. DuBose, and please take out a sheet of paper. Put your heading in the upper right-hand corner. First, last name, the period you have me, and the date. So this is a review for the test that you're having coming up shortly. And we're just going to go over the scientific method step by step. So some of these slides are going to be very quick because this truly is something that we have been working on for the first 5 weeks of school, and we should be well versed in it and well prepared for the test. So the scientific method involves a series of steps, and they're used to investigate something that happens naturally or a natural occurrence. The first step in the scientific method really is observation, as you have to observe before you can ask the question that is often considered step one. So problem or question, research, formulate a hypothesis, experiment, collect and analyze results and conclusion. So these are the 6 steps that we've been learning in order of the scientific procedure. You'll need to know them for the test. And you'll need to know them in order. So problem, question. You're either going to state a problem or design a question. That's the first step. And like we said, really the first step is observation. And in fact, some textbooks will say the first step to the scientific method is observation. But most say that it's stating the problem or asking a question. But you can't ask a question if you don't notice something that happens naturally first. All right, a natural occurrence. So develop a question or problem that can be solved through experimentation. And that's key also. It has to be something that can be solved through experimentation. The second step is research. It's important that you research your topic of interest so you can make a knowledgeable. Do you remember the next step? That's right, hypothesis. In order to make a very strong hypothesis and make a strong prediction, you have to be knowledgeable about the topic, your topic of question, or the problem that you stated. The best way to do that is research. Not only to rely on what you already know about the topic, but to do some research. Interviews, internet, library. We know that a hypothesis is an if-then statement and includes your independent variable and dependent variable. And we have certain ways that we've been learning in class to remember that if starts with I, and so does independent as an independent variable. As I am the independent scientist, I make up my own mind. Yes, all those I's, because the if portion of your hypothesis really can be thought of as the independent variable. And the then statement, or the second part of your hypothesis, is a statement of the dependent variable. So, if soil temperature rises, then plant growth will increase. A hypothesis also needs to be measurable. It needs to have a measurable outcome. All right, so if soil temperature rises, then plant growth will increase. So looking at this hypothesis that we have as the example, what is the dependent variable here? That's your first question. So put 1 in the left-hand margin, and I want you to answer it in the complete sentence. The dependent variable is, and explain it briefly. That's your measurable outcome. You will definitely need to know dependent variable for the test, and also how to write a proper hypothesis with an independent variable and dependent variable included. Next step, very important, is experiment. That's what it's all about, right? You're going to develop and follow a procedure. That's all part of planning a great experiment. Not only do you have a testable hypothesis, but that you also take time to develop a procedure, come up with the proper materials that you will need. All that needs to be included as part of the experiment. The point is you want it to be replicable. In other words, if somebody else wants to repeat your specific experiment, they can, because they know the materials and the procedures that you followed. All right, step 5 is to collect and analyze results. The collecting results really happens more during the experimentation part, step 4, but analyzing results is definitely the 5th step. After you have done the experiment, you take time to evaluate your results. What do you see? What can you tell? What are some conclusions you can draw? Analyzing results includes those tables, graphs, notes of observations, and photographs, all those things that you took in while you were performing the experiment. You're going to consider all of that as you're drawing your conclusions. That is analyzing results. And finally, conclusion. You're going to include a statement that accepts and rejects the hypothesis. You're going to restate your hypothesis for the reader. And most importantly, you're going to substantiate your conclusion of whether or not your hypothesis was accepted or rejected based on data. You're going to have to show data to prove whether or not your hypothesis was accepted or not. Other things that you can include in conclusion, and a strong conclusion will have these comments, is recommendations for further study and possible improvements to the procedure so that your outcome could even be more accurate. All right. Do you think you can name all the steps in order? Well, I want you to challenge yourself and to see if you can. That's important. You will definitely need to know that for the test. But I also want you to put number 2 on your paper, and I want you to answer this question. Why is it important to do research before you write a hypothesis? If you notice, and I'm sure you know this, that research is the second step to the scientific procedure, and writing a hypothesis is third. Why is that? I mean, hypothesis is just an educated guess, right? There's a reason why it is necessary and important that you do research before you write a hypothesis. Why is that? All right, challenge yourself. Can you name all these 6 steps in order? All right, so after that review, we're going to go ahead and look at something that may be considered a more realistic or real life problem that somebody could solve in a scientific experimentation. It's about 20 slides long, and I'm not going to narrate it, but you will need to read through. It's excellent review for the test. And also, of course, there's a catch. On one of the slides, there will be another question. So you'll read through, you'll pause it if you need more time to be able to understand what's going on that slide. And it's imperative that you do just that, because one of the slides you'll hear a question. So pay attention, listen, and be ready for question number 3. All right, so question number 3, put 3 in your left-hand margin. And the question is, why is it important to have constants in an experiment? They gave a list of what several of the constants are for John's experiment, but why is it important that he have constants, and all experiments have constants? That's your third and final question. Continue reading though, so you have an understanding of the experiment and the scientific process for the test. All right, so congratulations. This is the final slide, and if you made it this far, go ahead and put number 4 on your paper and write the word starfish. All right?